Okay, thank you, Helen, for that introduction, and thanks for the invitation to come. And of course, thanks to the GSQ and the Queensland Government for the funding so that we could do this project. What I'd like to present here today is results of the Airborne Geophysical Survey and the Interpretation Project that Longreach undertook over the Fletcher Awl permit in Queensland. It was quite a diverse range of work, which I'll show you. But my aim in this talk is really to give you an overview of what was done, give you a few of the outcomes, and give you a bit of a taste of what's contained in the reports and the data that will be available in a few months. A minute, I'll just click on that one. Okay, great. The Fletcher Awls project is located in the central Queensland area, northeast of the town of Claremont. Longreach number 1, which is a subsidiary of Longreach Mineral Exploration, did a regional project generation, or Kennex by Kennex, Proprietary Limited. And as part of this regional project generation, this area was highlighted. And it's located along a regional northeast-southwest mineralised corridor, including the Bandara Pluton, where Duke Resources is doing some work at the moment. The Fletcher Awl project has numerous gold, copper and silver mineral occurrences and old mine workings. The first phase of work that we did working with Kennex was to do a desktop assessment of everything that has been done previously, and this highlighted different metal associations and alteration assemblages. There's been, as I said, lots of exploration in different places. It's been a bit sporadic. We believe there hasn't been any systematic exploration, and there's still some untested targets with some promising prospects that haven't been drilled, and there's no deep diamond drilling. So rather than go all the way through, I thought I'd start with the final slide and show you the final slide and then work back. So it's presenting of the results. This is the solid geology interpretation on the left-hand side that was resulted from the Airborne survey. Sorry, my presentation's going a bit funny on my slides. And then on the right-hand side is a published available geological mapping. So by doing it this way, it means that as I talk, I can highlight some of the features. So this is the dome area highlighted in the middle here on the interpretation and on the mapping. So some of the exploration outcomes from this talk was that we refined and delineated the major geological units. We got better definition of the project scale structures and understanding of their geological and structural history. Obviously mapped the dominant fault extensions. And one of the things you can see, I've highlighted a red circle here. There's an Anarchy diorite that was mapped as Devonian. Looking at the intrusive and structural relationships, we believe that's younger, possibly Cretaceous. Using the geophysical data, we were able to recognise several buried intrusive bodies that lay below the main prospects and may represent a source of mineralisation fluid. And obviously, as part of the outcome, we identified prospective areas for further exploration work. And we also defined, got better definition of the young peak range volcanics, which I believe that Stuart, following me, will also talk about, which are of interest for rare earth metals. Sorry, I'm having a problem with advancing. Okay, so that was the last slide. So coming back to the first slide, the scope of the project that we did, as I said, was to give a better understanding of the geological structure and the tectonic evolution. So Longreach appointed Searcher, who I work with, to handle logistics and project management for all phases of the project other than stakeholder consultation. And the scope of the project was to acquire over 8,000 line kilometres of high-resolution magnetic and radiometric data. Fixed wing acquisition, we awarded the contract to Mag Spec, 50-metre line spacing on east-west lines and a 50-metre survey height. As standard for most of the work that Searcher does, we appointed an independent QC to look at the data, and we used Rainer Wackerle from Geo Intrepid in Namibia. And then when we came to the interpretation phase, we worked with a few different groups. So we had Terry Hosky from Alteryx doing some advanced processing and imaging on the data. Peter Kovac did the geological interpretation, solid geology interpretation. And then we worked with Kennex throughout to try some different machine learning algorithms and also construct a 3D geological model. All these reports shown there have been submitted to the GSQ as part of this project, so will be available. So coming back to the survey itself, this is the permit. This is EPM 2743 outlined in the outline here. This the survey area was actually larger than the permit size because we wanted to cover some of the other features in the area to sort of fully understand the dome. So you can see the survey area outlined in blue and then a flyover zone. As part of the mandate to stimulate exploration, we directly employed about 11 people in the course of this project in terms of contractors doing the work I outlined before. So from an HSE management point of view, we Longreach handled the stakeholder consultation. There was about 27 stakeholders notified for entry notices, including the various government departments. The Peak Range National Park, there's one area to the northwest and one to the southeast, and as per their advice, it wasn't possible to avoid them, but we significantly increased the flying height over these areas. We were hoping to have done data acquisition in September, but of course last year with borders closing and aircraft availability, it was a difficult year for many exploration contractors, so we didn't end up acquiring the data to January. We were a little bit concerned because of obviously temperature and weather conditions, but we got good flying conditions and there was no QHSE problems. They expected a really good job. We also had some of the landholders had raised concerns about effects on their cattle. There's some very high value bulls in the area, but they monitored those and there was no adverse effects on cattle in the area, which was good news. So we've maintained good stakeholder relationships from all parties. So coming back to the geology of the Fletcher Awl area, this is taken from a previous company report, but Fletcher Awl just sits on just to the eastern side of the Anarchy Inlier, a Neoproterozoic Cambrian inlier, and the dome itself you can see is cored by this Anarchy Inlier and the Ordovician Murruman granite. And then the dome is surrounded by a series of Devonian and Carboniferous volcaniclastic sediments, and then overlain by the Back Creek Permian sediments. One of the issues with exploration in this area is all this brown area around is tertiary volcanic. So they're very extensive. They mask the older units, meaning that sort of geophysical techniques are very useful in this area. And there's also younger peak range volcanics, which have been imaged very well in the data. And of course, there's late tertiary and quaternary superficial deposits. So I just want to show you a few images of the data. People that know me know that I love new geophysical data, so I just like sharing it. So on the left-hand side here, we have the government existing data at 400-metre line spacing, a colour reduced to pole image. And on the right, again, we have that geological map. So in the 400-metre data, you can see that the Murruman granite in the middle is fairly non-magnetic. You can see some of these units around it. And all this speckledy information, all this speckledy signature is actually the young two volcanics. We're also a little bit intrigued by this large magnetic feature to the southeast, which is part of the reason why the survey extended over it. And it's difficult, all these peak range volcanics mapped here. It's a bit hard to see them in the data. I'm just going to circle here some of these features. This is the Anarchy diorite mapped here. Devonian, you can see it's got a magnetic signature, and there's also obviously other magnetic features you can see even on the regional data, which are not shown properly on the mapping, on the existing surface mapping. So as a comparison here is a 50-metre line space data overlain on the regional data. So you can see the dome mapped in much better resolution. You can see the edges of the structures are nicely defined. You can see the units, and we're getting a lot more definition of these deeper, which are deeper magnetic features and which are shallower magnetic features. The closer line spacing and the lower flying height really allows us to resolve those features. And not so much the initial interest that we were in with the gold and copper side of it, but we can see these, these younger volcanic systems quite clearly mapped. And I'll show you a vertical derivative soon, which is even more spectacular, I guess. So we did a generation of interpretation images, including some depth slices. Again, on the left, this is a resolution of the new data. And then as we move across, these are pseudo depth slices. And in the deeper data, not only can, obviously see the deeper features, but I'd just like to draw your attention to this north-northwest trending magnetic feature that sits in here on the eastern side of the dome. So this is the first grayscale, first vertical derivative. So a high, emphasizing high frequency effects on the existing 400-meter data, and then on the 50-meter data. I'm not sure how good your screen resolution.
GSQ. Just ringing about your round 5 application for CEI.
Oh, I can see. Sorry, someone's got their microphone on.
0411 312
Helen, maybe?
355. Thanks. Bye.
Yeah, it's not me. I believe that might be Laura. So I'm going to just sort that out. Sorry, okay. Continue, Helen.
That's okay. That's all right. I got confused because it said something about, Helen. Anyway, so this is the data. Not sure how well you can see on your screens, but if you get hold of this data, you'll be able to see, some of these discrimination of some of these younger intrusives is quite stunning. Up in these areas where we had to increase the flying height over the Peak Range National Park, you can see the loss in resolution of the data, but the data quality is still good and still usable. It's just that we had to increase the flying height. And again, I'll just highlight this diorite, Anarchy diorite area and the dikes that are coming up to the north. So, not surprisingly, you go 8-fold increase in resolution of data and the results are stunning. So, and we acquired radiometric data. So on this image here just shows a radiometric total count. So the red areas are areas that are high in all radiometric elements. So the dome in the middle, the granite in the middle has got a high radiometric response. Some of the other responses are these peak range volcanics. You can see in different, they've got a general total count. You get a better discrimination though when you use a ternary image. So in this image, it's a red, very standard, red, green, blue equals potassium, thorium, uranium. And you can start to see discrimination of these different intrusive bodies based on slightly different ratios of thorium and uranium. This is a Mount Donald intrusive or outcropping, and I know that there's been already some work from the universities to sample it. It has a very high thorium response. We did generate different images of this where we were tweaking and stretching this in different ways, and got some quite interesting results in terms of the discrimination of these younger intrusives. But for a lot of our work for this stage, we were focusing on different areas of possibly increased thorium versus, potassium versus thorium for alteration for our potential gold copper mineralisation. And just a comparison again against the 400-metre data, the radiometrics in particular, the footprint just really sharpens up. And a comparison of the radiometrics with the mapped geology. Again, a lot of the units around the dome are reasonably well. The radiometrics will correlate well with the mapped geology because it's mapping a surface expression, but it does give discrimination of some of these other younger features of different styles of intrusives. One of the first things we did with the data was we tried doing, Kennex did some work with us on machine learning algorithms. We trialed different machine learning algorithms, and I'm not an expert on this. Well, I actually know very little about it, but we tried different random forest and support vector machines, so supervised and unsupervised methods. One of the problems we had with it was that obviously with the tertiary volcanics, that causes a lot of problems with the magnetic signature because they're magnetic. But we did find that the support vector machine produced the best result. However, generally, although the training points were correctly predicted, it was very hard to clearly discriminate between the different geological units. The geological units had similarities in geophysical signatures, so it was hard to use it as a standalone product. From an alteration point of view, we had, I guess, a fairly small training set. And so it was hard to, we didn't have enough field data to form a definitive link. So we will review that with the next phase of fieldwork. But what it was useful even at this stage was to actually have the outlines of the geophysical units, and that was used to guide our other geological interpretation work. So coming to the sort of more conventional geological interpretation of radiometric data, it's always hard to show these on a map on one slide, but hopefully this is the one I showed early on, but you can see the interpretation. So this was done by Peter Kovac, and we can see better discrimination, better structures in here, and more continuation of the units under the tertiary volcanic cover. So the layers of what we did in the interpretation, which again will be available, was delineated the major geological units, surface and subsurface, including, oh, sorry, that one hasn't come up on the screen. There we go. Including the tertiary basalt flows. We had an alteration map from the radiometric data, detailed structural map, and a solid geology map. We also did an unconstrained inversion of the magnetic data. So it really gave us a significant improvement in the project scale structures and an understanding of the history as well as targeting work. And we also were able to modify the tectonostratigraphic history. What I've outlined on this image here that wasn't on the first one is some of these areas of these subsurface magnetic bodies or intrusive bodies. So I'll just show a couple of quick snapshots of some of those other products or stages in interpretation I've listed here. This was inversion of the magnetic data. So what this allows us to do is to take that solid geology map here and just provide some 3D context of it based on the magnetic data in terms of the shape. So in particular, that Anarchy diorite I pointed out, you can see it's got a much larger, when we did the magnetic inversion, we've got a much larger depth extent of that body than what's shown at the surface. And it also links into that magnetic trend that we could see on the deeper magnetic slice. As I said, the other things we did was construct a tectonic evolution of the area. So Peter worked on it to try and link it in with all the literature around to try and build up the project. And in the report is a series of these cartoons of how each stage might be. In particular, in this one, I said this cartoon I've picked is just for the so the Permian extension, and whether there's I believe there's an extensional structure, and there was an opening allowing the deposition of the Permian basins, which are more extensive than what's been mapped. We can see on the geophysical data. The other point I'll mention here, I'm not sure I mentioned it before, was that the recognition of the Anarchy diorite we believe to be a bit younger, so we've put it in the strat column up here, and I'll come back to that later. As part of this regional study was to identify these regional zones, and again, just supporting that initial observation we thought about the alignment of the Fletcher Awl Dome linked to the on the same regional structural alignment as the Bandara intrusive. So the last stage of what we did was Kennex worked to construct a 3D geological model. So we used a solid geology map as a starting point, constructed some 2D cross sections. And then because, as I've highlighted several times, the exposure is limited to around the dome. There wasn't a lot of surface structural information to constrain it. So they used everything that else was available, the gravity data, the inversion of the magnetic data, and these cross sections to try and build the 3D model. So it was constructed in Micromine. I was hoping to have shown you a picture of it, but unfortunately I had a computer crash yesterday and I couldn't quite get it up. So I've just took a couple of snapshots from the report of how it was built, and also a section. So you can see the surface geology interpretation and then these series of cross sections that have gone into the 3D geology model. And really the insight was that it helped us to visualize what was going on, but also help map these deeper intrusives, or I guess visualize these deeper intrusives that we were seeing to try and predict where the mineralization may have occurred in a 3D space. And this model can be updated as we get further drilling results. Oh, sorry. So I'm not quite sure I'm going for time, but just wrapping up, this is an interpretation slide, and what I've done here is also overlaid on top of it some of the rock chip results so you can sort of see where the known prospects are relative to our new structures. So the results was really refinement of the major geological units. So the surface units, getting better definition of those and taking them further into the subsurface. Better definition of this Anarchy diorite east of it. And what I highlighted on before is that looking at the data, the detail we got in the data, so based on our intrusive and structural relationships, we believe it has to be younger than previously mapped just because of the age of the dikes to the north. So we're postulating here that it may be Cretaceous, similar to the mineralised Bandara Pluton. From the magnetic data on some of those depth slices and things I showed you, that we definitely recognise additional magnetic intrusives at depth, and the magnetic inversion of the 3D model indicate that these are potentially connected to the Anarchy diorite and positioned below a lot of this known mineralisation. The radiometrics confirmed what had been already noted. There was some alteration in some of the alteration systems, and in particular some increased potassium alteration around the diorite recognised from the radiometric data, but also the magnetic data. And so the dikes and the faults, we can see in the interpretation here north of the diorite, we think maybe represent conduits of the mineralisation from these underlying intrusives. The structural interpretation here, which has defined these northwest and northeast structures, where there's the extensional sections, either the intersections of the faults or the extensional segments of these faults, could represent good locations for deposition of mineralisation. So our targeting work will be focused on the combination of all the information we've got from this study. The other layer that we've got in the data is we have also had further definition of the flows of the younger peak, or the intrusive, the peak range volcanics of interest for rare earth metal. We haven't done enough work yet to understand what those different radiometric responses have got, but it's certainly we've been able to map them in further definition. So all in all, I think we've advanced our knowledge of the area a lot. We've confirmed some of the areas of interest, but also extended to new areas of interest, changed some of the ages of some of these intrusive systems, and just been able to focus our work for our next exploration. So that's the end. Thank you.
Thanks, Helen. That was fantastic. The resolution on that mag data is just, I love it. Working with big scale surveys, really appreciate it.
But frustratingly, of course, it'd be lovely if we could just have another glaciation episode and get rid of those magnetic volcanics. I'm not sure if I emphasised that enough, but a lot of the stratigraphy that we're after is still essentially non-magnetic, and it's very hard to see through those magnetic units. So
for sure. That's great. All right. We've got a couple of questions. Nick Oliver says, good stuff. And John Menzies, who is joining us from Cambodia today, has said it would be interesting to evaluate the whole rock and trace element geochemistry for all of the outcropping intrusives. Is that something that you've considered doing?
Sorry, the whole rock, yes, I think so. And also obviously do some dating on those intrusives, because a lot of exploration, previous exploration has been very focused on just doing a few elements, and even that whole rare earth metal story that's evolving, and I'm sure we'll learn a lot more from Stuart, but that whole a lot of those intrusive things have not been sampled properly. I know the universities, ANU and South Australia University or Adelaide University, is sending students up, so I think there's going to be quite an interesting story coming up from that whole area. And it was even hard when we were trying to work out the tectonostratigraphy, that in terms of what the of which units, what ages were what, when you're trying to look through the literature. But yes, definitely that's on our list. When we go into the field, we will be doing that element geochemistry.
Oh, does anybody from the panel?
XRF, good idea.
Yes, portable XRF. Does anybody from the panel have any more questions for Helen?
I had one. Can you hear me? Yeah.
Yes.
Were there? I was also really impressed by the. It's always nice to see much higher resolution magnetics. It's almost like you take the Coke bottle glasses off and you can actually see what's going on. But the question was, were there any sort of obvious mineralization targets that emerged from the data, or any sort of really high priority areas for further exploration that
Yeah, certainly around the that diorite that I pointing both from an intrusive source and also from an you can see the alteration, but also structurally, not surprisingly, where you've got the northeast southwest structures wrapping around those intrusive, as in the areas you'd expect to be little dilation zones. Sure enough, we're seeing some increased radiometric response, and some of them link with known mineralization and some of them don't. But the diorite, there's not, I think probably about 30% of it is outcropping, but the rest of it must be very near surface. So in the reports, we have put all that information in about our prospectivity and where we're going to go. I just wasn't kind of sure how much to cover off in this. I sort of more want to tell you the scope of what we've done, but we're happy to share that work that's all been submitted. So
it has, yes, and I know that our geophysicists really enjoyed reading the report, and when we were looking for speakers for today's session, you've got to get long reach. So
yeah,
really appreciate
so I mean,
that.
I'm happy to show those or whatever. I just didn't quite know how focused this was about sort of showing a little exploration story versus a technical story about the data. But there's certainly the target zones around the diorite, following those dikes, and just localized places around the dome, particularly the structural intersections.
We do have a question online.
And going and sampling those peak range volcanics, but
yeah, I know they're intriguing. So I wonder if, I think somebody might have missed it at the start, but we've got a question from the audience about what you were targeting, and I remember you were saying was a silver gold system.
Oh yeah, sorry, yes, it was. I guess, and the original thing was a fairly generic, porphyry epithermal intrusive related gold copper system with silver, and that's still, we still think it's a similar system. We what I didn't really focus on is the survey did partly cover that big magnetic system to the southeast, which is still a bit unknown. The gravity data is not very good down there, and there's not a coincident gravity magnetic thing, but from the data, it doesn't seem to have an obvious structural connection into Fletcher Dome, which was one of the questions we wanted to have answered. But yes, it's definitely still chasing gold, copper, silver, intrusive related, and more related.
I might have missed this, but did you guys collect your own gravity as part of this as well, or has there been gravity collected?
No, the gravity is relatively coarse through there, and as I said, it is a bit weird that that, and I didn't talk about it there, but that big magnetic high in the southeast isn't coincident with the gravity. But whether that's a sampling issue, you've also got the peak range park and some peaks. I don't know the age of the gravity, so some more gravity would be useful for the more geological understanding. Yes.
It'd be great if the Geological Survey of Queensland did that, wouldn't it?
Brilliant. Maybe I need to put another application for another grant.
Please do.